Hello. Today we will be continuing a bit from what we worked on the last time, which is shrinking the priority index. The priority index is, as a reminder, a special index that is an inverted index that contains only keywords and documents that have some property that we think they are important and we would like to prefer them in consideration when evaluating a search query. And this index is unnecessarily large because it was interlacing the position, or rather the document IDs with the metadata that we aren't interested in. This should only be a list of document IDs. And last time I made these changes and I ran like a couple of tests and I couldn't find any issues, and then I wrapped up the video and went off to test this in pre-production, which is the old production server still sitting in the living room. And what happened was that fairly immediately there was a bug that was very easy to fix, just something that hadn't cropped up when I did some testing, and that's just how it is. But when I did fix that, the files shrank as we had anticipated, about 120 gigabytes smaller. But then I went to investigate the files because I wanted to do some analysis and figure out, can we compress these in some trivial way? And then went to move them to my workstation, and I ran out of disk space, which was a bit curious because I had enough disk space to fit the files. And after some investigation, it turned out that when I transferred the files to this machine, they became larger than on the host machine. And this took some head scratching. It turns out that these files were created as sparse files, which is a Linux concept, where if you have holes in a file, sometimes the OS will actually not store that data. It will just leave an empty block, basically. And that's a bit curious, and I did some more investigation. I figured out there's a bug somewhere in the index construction where it's leaving empty space in the disk allocation. And because it's a block-based data structure, this doesn't matter. They still work. It's just that there's emptiness between the blocks. So this is something that won't be addressed today. I think within the scope of the pull request I'm working on, I will try to fix it. But that's mainly because it's the only sane time to be doing it, because it will almost definitely break binary compatibility, and this is a change that will already break binary compatibility, so there's really no better time to be doing this. But yeah, this is not for today. And as for compressing the index, this is also something that we won't be doing today, but I ran some tests and then basically looked at the deltas, and they are all over the map. And this has to do with the fact that the document IDs are constructed out of 3 fields that are concatenated like on the bit level. So you have a doc ID that's the first 26 bits, and then you have a domain ID that's 31 bits, and then you have a ranking components that's only in place to ensure that the highest ranked documents are sorted first in the index, so that if we run out of compute, they are always found early. So this is going to require some less trivial encoding. We can't use like alias gamma or delta encoding or something like that. We need some custom codec for this, but I think it's doable, but it's not something that we will be looking at today. Instead, what we will be doing is removing the btree index components from just the positions files, should be saying the priority files. Since we aren't ever interested in finding whether a document is present in this list. We're only interested in reading it back, and we don't need an index. We can just have a flat list, and this is going to help us if we move forward toward compression, and then we can just extend this change. And finally, I think we need some tests because obviously if something runs on a test environment and a test crops up and it hasn't cropped up and when running the unit or integration tests, and then something is missing. And I think what's lacking is coverage for larger data, because there's code that's only run when you need to merge pre-indexes. So we'll try to put something in place in that regard. But first of all, we will rip out the btrees, and so let's get coding. This is the finalized method that's taking pre-index data and constructing a finalized version that's usually consisting of segments of data with their own separate btree structures, and these are like on disk btrees, so they're all like implicit arrays and so on. And what's going on is basically this is where we need to make a change. We're allocating file, memory mapping it, and then we are opening the input channel, and then we have an array that consists of the offset to the end of the data segment for each block of documents for a keyword. And then we pass it into this transform each IO method, and it takes an object here that's doing this transformation. And I'm actually noting here that this force call we should be removing. The force pushes changes to disk, but this is the input channel, so this is a read channel, so there's really no point to forcing it to disk. I think it's some old change. The final output file is forced over here as well, so we don't really need to worry about that. And I also think this shouldn't be an array. We should be using a channel. And these long array objects, they're part of the Marginalia code base, and they're used for like random access, and they're based off either memory segments or unsafe. But since we're not going to be doing random access, we're just going to be copying data right now, we should be using channels instead. And then we don't need this size estimator either, because when you're memory mapping, right, you need to tell the call how large the file you want to map. But when we're just writing to a channel, we don't need that. We can throw this guy out, and we can throw this guy out. Actually, we need the output file name, and then we should be I think it's this guy we want. Right. And this prio btree transformer we can rename to something else. Prio doc IDs transformer, say. And it should be taking a destination file channel. And these transformers, they're a bit involved. I will briefly touch upon what they're doing, but first I will make this change. I need a btree And we don't need an entry size. Right. Throw that out. Let's go back over here. Throw this guy away. Throw this guy away. Test file channel. Miss it. I can actually do like so. Like so. This transform each IO method, it's iterating over all the positions in the array and calling this long IO transformer with the positions in the file and the data in the file at that position, and it's a long. And what this transformer is doing is it's storing the previous end value because this file, as mentioned, it's basically containing the ends of the data segment. So if you have like doc1, doc2, doc3, here's an end, and then there's doc2 and doc3, here's an end. And then you have a start field that's 0, and then you have 3 that start and end, and then you basically move this is the argument you take past in, then you move it over here, and then you get 5 like so, and then you get something else over here like so. This abstraction isn't super clear, but it's a neat way of doing it, and I'm probably not explaining it very clearly either. But it's neat and it's battle tested, so I am happy with that for now at least. Possibly this could be moved out, but this is probably not the time to be doing that. So what do we need to do? This data we want to write, we should be prefixing it with the length of the segment, which should be an integer. This based on my testing, like the longest list of document IDs was like 16 million, I think. Should this be a long? Oh, that seems a bit unreasonable actually. Maybe we should be doing like an unsigned int or something like that. Because if we use a 64-bit size field, then we're going to have a fairly considerable overhead. And this is part of what we want to reduce. On the other hand, it isn't that much, and we're like not that limited in terms of space. Well, actually, let's do 8 bits, and then we can check how large the file becomes, and we can calculate the overhead and see if it's acceptable. We can always change it later, right? At any rate, let's allocate the buffer to be writing this in, and I think this is actually a bit large. Like so, maybe. Does this make sense? Probably. And then we want to clear the buffer, put the size, and then we want to How do you do this? How do you do this? I should be setting a limit on the buffer that fits the data. Like so. Then we like so. This returns how much we have written. We create a field to store how much to be written, and it should be size plus 8. Right. Move this guy up here. To get some visual noise out of here. So what do we want to do? We want to copy data into the... Actually, we want to, first of all, we want to do this intermediate channel position, and then we do... Then we do what? Start. So now we will be reading into the right buffer at least once. And then we will be flipping. So. And then we should be doing so. Right. So. And we also need to iterate while reading. Do this. something feels a bit off about this, to be honest. Let's see if we can reason about it. What are we doing? Let's rename this guy. Let's rename this guy. So, what are we doing? We are clearing the buffer because it might have some junk. We're putting the size, and then we are adding a limit. This should be up here, I think. Actually, can we do this instead? I think this is what I was trying to do from the start. It should be 8 plus size. And then we can have to be written. We just subtract how much we have written. Like so. I think that makes more sense. This size is in longs. So we should actually do so. And this is in bytes. So that's what we're getting from this guy. I think we should be doing this as well. Just to get some sort of sanity. Set for block. This is right offset will change, so that's why we can't use it. Right. 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 I feel like this is begging for some sort of a test because it's very easy to miss like a byte to long conversion or vice versa. So can we test this somehow? I think we should be able to do that. Generate a test for this. So let's do this for guys as well. So actually this should be in the construct or the setup method. So we don't have to deal with exceptions. We can do it out here as well, but I think it makes sense to do it over here because we might have multiple tests at some point. But first of all, what we want to write a file that's a bunch of longs. And it's the easy way of doing this. Maybe we should do that upstream like so. That makes sense. That makes sense, I think. Why do we take file channels here instead? Suppose if we just do this, we do actually need the file channel interface, or just actually yes, we do need it because we need to be able to position these guys. So let's file channel. And this is not an auto-closable, so let's do that. And exception. What are we returning in here? Let's not have an assertion, first of all. I think we should be doing a so these guys should be in private resources. Oh wait. What are we? This is the right channel. Can we do this? We don't actually want it to be a right perfume. We want it to be like this. Right, so maybe let's see if this is doing anything like what we expect. I don't know. This guy is complaining. That makes sense. Where did the test go? I don't know. Over here. Channel not writable. Did this guy end up in the wrong order? Right channel. Sorry. All right, so that seems to be working, but we actually want to can we reduce this by like a huge amount just to see if it's working? Let's add 24 bytes. Yes, it's still doing what we expect. 0, 3, 1, 5. And then we expect this, and then we expect so. All right, my bad. This is not looking correct. This is looking misaligned as all hell. Why is this happening then? Right. So I think that makes sense. We were reading from the long offset and not the byte offset, and this is actually why it's very helpful to be using these suffixes to inform whether this is a byte offset or a long offset. And I mean, I've gotten a lot of crap on various forums for this take, but actually having pointer types like C is very helpful compared to doing this where you have no types at all and you have to like manually do the bookkeeping. But all the Rust people crawl out to the woodwork and tell me that why would this help at all? This is why it helps actually. I don't want to be crapping on Rust, but some of the community is a bit aggressive. Right, so I think this is working, and we want to restore this to the larger original value. Even though we aren't testing this, I think it's fine. I don't plan on poking around too much in this stuff. Right. Next up, we need to go into the index reader. And this shouldn't be memory mapped anymore. And now we're hopefully, let's just have another check here before moving on. Wasn't this the file we were editing? Yes, it was. It's a very long class, this guy. We have altered the finalize method, and we have replaced the transformer. This should be the same. I mean, we don't need to force anything because we are closing it. So that should be fine. What we need to do now is update the reader to understand this, and we're going to need a new entry source as well. It's used. Right. Right. So long array documents we will not be needing. We will not be needing this B-tree reader. Or data offset. Did I remove the words B-tree reader? This guy we still need. That's for reading the keywords file, which should still be using a B-tree index. So that's fine. It's basically storing the document file offsets in the interleaved with the keyword identifier. So that's fine. And then we have a look at this creating reader. We can remove. Now the question is, how do we read this stuff? In a way that makes sense. How do we do that? How do we do that? We want another file channel, I think. We can do reads. Only problem is this guy, which only wants to read the first value. I mean, it's just a basic read at the offset, so I think we can use a random access file here. So we want and then we do want private file random access file documents ref. That's how we can do it. And then we also want to close this guy. Document channel close. There's not really all too much to do if this blows up, I think. Maybe we shouldn't. Yeah, this is fine. We will just be logging it because we don't want the entire system to blow up. Right. So number of documents should just be a matter of we do this. It's super long since I used this guy. Can we look at the Java doc? I know you're supposed to be able to do like random reads with it. But maybe I've gotten spoiled with my long array file. Does it not allow me to do just... Now this guy is useless, let's not do that. Let's do this instead. We don't go to the ref. And we basically do... And this guy wants a byte buffer, of course. I do wonder, can we... Actually, I think it's probably fine to allocate this because this is not a very hot method. So then we... So this is not working. It's been hot minutes since I did this. Actually, I think I need a file channel, and that's why it's not having the interface I expected. And byte channel is like just a stream, I think. Yeah, read is what I wanted. That makes more sense. That makes more sense. We're actually casting it down to a long, but I think that's fine. And we actually need to create an entry source for this because the existing entry sources are they aren't doing what we want it to be doing. I know I was going back and forth on this yesterday, whether it should be full and prio or a shared one, but now we are going to be having a full and prio because they are going to have different structures. And I missed a key press. So that's strange. What I'm doing. Mattress was the guy I wanted to. I wanted to be copying. This word ID is only for reference, right? Yes. Long query buffer. Right. Entry size we do not need. So what are we doing in this guy? These entry sources, they are used to read data into a data structure that's used for doing the query, and you're basically filling up a bucket with document IDs, and then you have functions for intersecting it with other lists of positions. But since we are redoing this, then there is some differences because we're not using the long array class to access the data, and we are not using btrees. So we're going to be re-implementing some logic here. So a lot of this is assuming a long offset. So we want a file channel. Do we need a buffer as well? I feel like long query buffer should be able to read from a file channel. I think at least. Let's see, what do we have in this guy? Segment long array. We have a transfer from. Do we have a transfer to? I don't think so. Can we get like a byte buffer slice from this guy? Possibly. We can get a memory segment. And if we get the memory segment, we can get the byte buffer. So that's actually fine. So first of all, we want a number of entries. Because we can read this already, we implemented a method for that just a moment ago. And then end of set is going to be position plus number of entries times 8. Or should this be in longs? Yeah, I think it should be in longs. Let's decide it's in longs. And then we need a long data set start. And this is in bytes. Let's start with the typing immediately just to maintain some sort of sanity. That makes sense. And this isn't actually, this is unitless actually. Actually, well, let's call it longs because it's effectively is. it is always implemented right. Even in unsafe, yes, that's true. All right, so how do we do this then? Right, we want this as a buff. And why is this complaining? Because it's a prio API, but that's because I'm on an older Java version, which it isn't actually. So let's ignore that. Did we get the file channel? No, we didn't. We can insert that as well. So what are we suggesting here? We definitely want this guy, and then we want so. And this is complaining about IO. I think that's fine though. Let me do this. And we can actually just sneak it throws this. I think because there's not really much to do in terms of handling that error. Right. It's just going to be blowing up, and that's maybe to be expected. So what are we actually doing here? We are setting the end of the buffer. We're setting the end of the buffer, and then we are getting the underlying memory segment as a byte buffer. We are clearing the buffer, setting a limit. We are, while the buffer still has elements in it to be populated, we do this read call, and we're incrementing the offset. Actually, yes, we should be. We need to increment something else as well. Otherwise, we will be reading from the same memory location over and over and over again, and that's not what we want. This guy isn't like returning 0 or -1 or something like that. Yes, we don't do that. I don't know what to do about that. That's some sort of hardcore error, so there's not really much to do. Like so, that's what we wanted to accomplish. Now it should be advancing with every read call, as long as we have remaining. Actually, we could probably do byte buffer position like so. That will have the same effect, but we still want to keep the check for end of file. Otherwise, this will loop forever if for some reason the data is malformed, and we don't want that. We want to fail, obviously, and early. Right. We're updating the end position appropriately. This seems correct. Yes, to the extent of my ability to reason about this code, I think it's correct, but it's pretty difficult to reason about. So, yes, I think we need to actually copy this guy over here as well. It's not super desirable to do that, but so, and then we do the channel. And this should be an int. And what is this guy? Data offset. It's this one, right? Offset +8, because we're not going to be including the count. So yes, I think that makes sense. And we're logging. There's an error. Right. This is not always constructed. Why is it not always constructed? Because we have a return statement over here. And then we do null this guy. We want to semi-gracefully deal with the fact that we don't always have files on disk. We still want to be able to bring the system online if that happens, even though it's not going to be obviously responding to any queries. Right. Do we have any tests that cover this already? Is the question. Let's go to the index. This is the guy I was editing last time. All right, I think this is actually, this is the correct test, but it has the wrong name. But I think that's fine. Let's do this then. Let's rename it. There's some stuff I want to test here. I want to make a test where there's a huge amount of data, first of all. How can I construct such a test? And this is taking an array, right? And these are like so. Well, mind run. And this should all have the same. Actually, this should have different document IDs. So let's do 100 plus I. They all have the keyword 50. It's fine. Let's do large data. Right, and then we expect 32 items, and we expect we should just get the data in. So let's not be needlessly stupid, even though obviously this is test code. So super matter. What are we seeing in here? 100 plus I, right? And now we're getting the correct data. Let's try to fill the buffer again. I don't remember if there's something you need to like clean the buffer before you do this, but let's find out if this works. Oh, hey, it's actually working. That's cool. That's very cool. It's like unexpectedly cool. There's something when you're live coding like this, because you're talking about what you're doing and you're like needing to scrutinize what you're doing, that makes it so that you tend to make fewer mistakes, I think, because this is a fairly finicky change, right? And there's been some head scratching along the way, but for whatever reason, it seems to be working. And I know I've spent like previous videos desperately trying to find bugs in the code. But maybe I will have to accept the fact that actually working like this is a pretty good way of producing good code. Because again, like when you're doing these sort of finicky changes, it's very easy to accidentally mix up a byte offset with a long offset or something like that. And even though I'm trying to be careful and using these suffixes to distinguish the two, it's very easy to make a mistake like that, or forget to advance some pointer somewhere or something like that. And I would expect the first time you test code like that there's some problem somewhere, but it seems to be working. But I think this time as well I will be doing what I did last time and deploying this to the pre-production server, which will run a lot more data through the code, even though we like put 1,000 items in there now. Actually, maybe we should be doing like so, or like so, because this will definitely go outside the any buffers we were using. So let's try this as well, just to see if it blows up. No, it doesn't. That's cool. Right. So let's see. Compose. And this is a cold start, I think, so it's going to take a moment to spin everything up. So can we do some basic processing just to test this? Can we? Yeah, it's catching me like off guard all the time when I'm live coding like this, how much more robust the code ends up being, because I'm used to making more mistakes, I think. But something about this, like narrating what you're doing and needing to explain your thinking and so on, I think it leads to more robust thinking, even though I'm rambling and sort of fumbling my way forward sometimes. It's still apparently very useful. Let's just do like this, and we are not getting any exceptions anywhere. Let's see. Index 1, index IR. And the prio docs file is relatively small, at least. This is this is actually what I was scratching my head over yesterday, but the holes in the files. Here, this is 1.7 megabytes when you're using LS, and it's 1.2 when you're using DU. That's a bit of a head scratcher, actually. But this one is consistently the same size. Right. I wonder if this is something I want to commit. Let's go over it and see if we have like some unused imports or some weird mistakes somewhere. Yeah, this is just when we rename the the reverse index entry source to full index entry source. And here we are replacing the reader in the full we're replacing the entry source in the full reader, and that's fine. This transformer guy, let's have a look at this. This is a new class entirely. This transformer object paradigm is probably something that would be beneficial to replace sometime in the future. Actually, this comment should be like so. This paradigm is probably something that we may want to get rid of, because it's kind of difficult to follow when you're like looking at this. You're doing like transform each IO, and then you're passing in this object that's like storing start addresses as a field in the class and so on. So yeah, I was happy with it when I implemented it in the first iteration of the code, but I'm increasingly feeling that this is hard to follow and should be cleaned up somehow. Right, but as far as ID transformers, lock-ID transformers, this is relatively fine. And allocating this buffer is fine because we're using this transformer to write the entire file. I think the buffer size is fine as well. It should be a couple of disk blocks, and that's roughly the granularity you want when you're writing stuff to disk. Possibly we should be... Actually, that's an interesting thought. Maybe we shouldn't be writing this to disk except when you are... when we have filled up the buffer, because now we will fill it up a tiny amount and then we will write it to disk, and that's not a pattern that's great. Yeah, I think possibly we should be changing this, but before I do that, I will finish this review. Right, this test, this is complaining about some old failure. Should we add some comments about what we're doing? Yeah, maybe we should. So even though these are like I++ tier comments, I think it helps a bit to have some sort of guidance when you're looking at stuff like this, and remove some of this Copilot generated nonsense. Right, then we are deleting the files, which is always desirable because it's not nice to have like a temp file that's full of output and input that. Right, and then we're looking at the entry source. I can actually do this to get rid of the noise. I don't think there's much to be said here. This like unique call. It's questionable whether we need it, but it's done in the other entry source, so let's do it here as well. Actually, we don't need it. We have these like index name things that are useful when debugging to figure out where the data is coming from. Right, but this looks fine, I think. Pre-index, what have we done here? This is to finalize. Yes, and remove this force call, which doesn't do anything because that was the input file. The pre-index test, we added another test that tests with more data, and that's something that would have probably triggered the bug I mentioned I had discovered the other day. And then we have the reader. We are replacing this long array with a file channel, and we are using new entry source instead. It's a bit unfortunate that we need to do this this stuff. But I don't think it matters because this call isn't super hot. It's a bit ugly to get this duplication, I guess, but I'm willing to accept that. Maybe we should add a comment to say what we're doing. This isn't this reader is used by multiple threads, so we can't like trivially buffer these byte buffers we are allocating or cache them somehow. We could use like a thread local or something like that, but I don't think it really matters. This should be fairly trivial to garbage collect, so that's fine. And they're tiny as well, so right, that's not much to say about. So the question is, do we want to this transformer guy, do we want to clean this up to gather up the rights to a more contained rights? I don't know. I think what I would do is push this to the branch, and then I will deploy it on the test environment and basically reconstruct the index and just see how long it takes. If it's tolerable, then we won't do that. Because it's already quite fast. We're getting rid of many of the steps that are slow, so it could be that this is an optimization that only adds complexity, and I don't think at that point we want to do it, because this is, even though this is fairly difficult to follow, it's still easier to follow than if you have like state that's persisted in a buffer between calls. So yeah, I think I will be pushing this in. What do we want to say here? We want to say removing bttree indexes from so I think, is there anything to add to this? Let's just list what we're doing. We update the finalist logic with a new with a new IO transformer that copies the data and nice. And then we update the reader. And then we added a test. This isn't perhaps the best git message ever, quit message ever, but I don't know what to add to this. There isn't a lot of reasoning to this, I guess. I guess we could say it like that, because that's why we're doing this. We're only ever reading this documents lists back and not intersecting them with anything. So yeah, something like that. Right, so I will push that in. And then I will deploy it on the pre-production server. But I won't be filming that. So let's wrap this up for now, and we can come back to either fix whatever bugs have cropped up in testing this with real data, or maybe think a bit about compressing the data as well, depending on how large it is. If it's getting down to relatively manageable sizes, if it's like, let's say, below 32 gigabytes, then I don't think we need to do that. But if it's still fairly large, then maybe we should think about compressing the data somehow. Right, but that's it for now.